Hi there guys, welcome to my first video, and today we'll be looking at some common misconceptions and try to fact check them and have fun. So I have two Google tabs and ChatGPT just in case, and we're also going to need a console for doing some math. Okay, so clean search history, very important guys. So we'll just go ahead and search for common misconceptions. And well, I have started looking at just the first two, and I thought it'd be nice if I didn't look at them. Yeah, the first one, so the list is actually very long and I think it'd be a nice series to just go through some of them. And the very first one is there's no scientific evidence that the motion of stars, planets and other celestial bodies have effect on our lives. So basically just saying astrology is fake. And so there's nothing to debunk here actually. I think it's pretty smart to just skip this one. The least I would say is though people should have the freedom to believe in astrology, just like religion, you know. But yeah, the next one, this one is quite interesting. So astronauts have the sensation of being weightless because they are in free fall around the Earth, so they're constantly falling. So that's actually what's happening, but not because they're so far away from Earth that its gravitational pull is negligible. And on the ISS, the Earth's gravity is nearly 90%, as strong as the surface. Okay, so we'll fact check this one. And for that, we need a function that gives us the force gravity. And it'll take m1, m2, and the distance between the two. And obviously we need the constant g, which is gravitational constant, which is this thing. So g equals 6.67 e minus 11. And then the force would just be, we should all know this by heart by now, m1 times m2 divided by distance squared. There we go. So now we will need the mass of Earth, which is this thing. So constant mass Earth equals 5.97 e to the is it 24? Why does it look so weird? Okay, so e24 kilograms. Okay, and then I mean the mass of the Earth and the mass of the ISS doesn't really matter, but for the sake of the video we'll just be doing this. Mass of ISS, it's this much, constant mass ISS equals 419,725 kilograms. All right, so we'll also need the radius of Earth, which is this many kilometers. So we're in IS system, so we'll need to convert that into meters. So radius Earth equals 371,000 meters. Okay, mass of well, we already have the mass of ISS. I meant to search for the altitude of ISS. So it's constant altitude ISS 408. So this will be in meters. Okay. So now comes the calculation. So we're basically just saying when we're up there, it's 90% of what it would have been at the surface of the Earth. So force, we'll call it F surface, will just be force G of the mass Earth, mass ISS, and the distance between the two would just be radius Earth at the surface. And then so this will be in newtons. So force in orbit, right? So force orbit. So when we're up there is force G, mass Earth, mass ISS, radius of Earth, plus actually the altitude. So that will be the new distance. So that thing is equal to that. So we're saying it's 90% of that. So F orbit divided by F surface, 88%. Pretty close. So we have fact checked this, and the facts are working, and we're happy. And don't forget to like and subscribe, and maybe let me know in the comments below which facts or the misconceptions I should tackle next. See you with the next video, and bye bye.